The MiG-27, known by its NATO reporting name Flogger-D, was another ground attack variant of the MiG-23 family. Despite incorporating advanced technologies and being designed for modern tactics, its performance was only marginally satisfactory. Today, we're investigating the MiG-27, the story of an attacker from a different time. The MiG-27 was intended to be an improved version of the MiG-23BN. Mikhail Igorevich aimed to address the shortcomings of its predecessor, but the Flogger-D retained many of the issues from the MiG-23 family, and its new technologies introduced additional problems. Ultimately, all operators retired the MiG-27, while the so-called failed MiG-23BN remains in service. As discussed in our MiG-23B BN video, the Soviet Air Force introduced these aircraft as an interim solution after spending 25 years refining its ground attack doctrine. However, the Flogger F and H only partially met the requirements. In response, Mikhail Igorevich developed the MiG-23BM with structural improvements, new targeting equipment, and enhanced armament. The MiG-23B and BN featured minor modifications except for the nose section compared with the original MiG-23 interceptors. Since a strike aircraft did not require high speed or altitude, lightweight fixed intakes replaced the original adjustable ones with a significantly increased air intake area, reducing the weight by about 300 kilograms. Its leading edges were also rounded to improve operating conditions at subsonic speeds. Mikhail Igorevich equipped the MiG-23BM with a digital computerized targeting and navigation system, reconfigured the nose section to house it, and modified the frame layout. The 23mm Gsha-23L on the MiG-23B and BN was ineffective against many Western armored vehicles, prompting the Air Force to seek a more powerful gun. Initially, a 45mm weapon using a rocket-assisted projectile was considered. Still, due to time constraints, a new 30mm multi-barrel cannon based on the AO-18 of the AK-630 close-in weapon system was selected instead. To reduce weight and size, engineers removed the forced liquid cooling system and the removable ammunition box and shortened the barrel block. These features were unnecessary for an aircraft cannon anyway. They also relocated the under-fuselage hardpoints to the air intake ducts to facilitate ammunition loading, while redesigning and strengthening the landing gear to balance the increased maximum takeoff weight. The first prototype MiG-23BM, powered by an AL-23 F3 turbojet, made its maiden flight on November 17, 1972. The second prototype also used this engine. During trials, the new 30mm cannon with extremely powerful recoil was the main challenge for Mikhail Igorevich. The first in-flight firing caused all cockpit instruments to fail after a 25-round burst. Later tests resulted in deformed or detached nose landing gear covers, destroyed ammunition sleeve due to severe vibrations, and failures of electronic equipment. To reduce these adverse effects, engineers tilted the gun's axis downward by 1 degree and 13 minutes. Following partially successful trials, serial production began in 1973 with aircraft equipped with the R-29B-300 turbojet engine. The official designation was changed to MiG-27 in 1974. In 1975, the first aircraft were delivered to the Soviet Air Force for user testing. The MiG-27 became operational in 1976. Production ended in 1978 with Mikhail Igorevich delivering a total of 360 MiG-27s. Compared to the MiG-23BN, the MiG-27's maximum takeoff weight increased by over 1.8 tons, affecting takeoff performance. To address this, Mikhail Igorevich equipped the Flogger-D with tilted, vertically rotated main landing gear and lowered the wheels by 175mm to reduce takeoff drag. The landing gear struts and shock absorbers were reinforced and wider wheels were installed. The initial nose wheel steering mechanism was inherited from the original MiG-23 and often failed at maximum takeoff weight. It was soon replaced with a reinforced one with a reduced steering angle from 40 to 30 degrees. The increased ground clearance of the tail reduced accident rates. During landing, the pilot needed to monitor the throttle lever closely to prevent a sudden drop in engine speed. The drop tanks also had to be jettisoned as they significantly reduced lateral stability. If the aircraft skidded, exhaust gas temperature could quickly rise to 200 degrees Celsius due to a flow stall in the air intakes, increasing the risk of engine fire. To address the problem, the MiG-27 was equipped with automatic fuel cutoff and anti-surge systems. Since the Flogger-D stalled without warning at critical angles of attack and could quickly enter a spin, giving the pilot only 1 to 2 seconds to respond, the aircraft had the DUA-ZM angle of attack sensor. However, the sensor was unreliable and incorrectly positioned, so it was relocated, and a second one was added to average the readings and reduce error. During supersonic flight, compression shocks from the fixed air intakes caused a loud humming in the cockpit. Initial MiG-27s lacked an armor plate around the cockpit, unlike the MiG-23BN. However, after combat experiences in Afghanistan, such protection returned. Equipped with the SPO-10 radar warning receiver, the MiG-27 had the PRNK-23 mission computer, which carried out functions such as flying a pre-programmed route, conducting navigational bombing, returning to the base or 3 alternate airfields, or performing a pre-landing maneuver. The digital computer simplified sighting equipment, improved toss bombing accuracy, and significantly reduced the pilot's workload during engagements. Throughout MiG-27 serial production, the PRNK-23 was continually refined, which expanded the system's capabilities. The MiG-27 was equipped with the 30mm 6-barreled Gusha 630A rotary cannon with a rate of fire of 5,500 to 6,100 rounds per minute. Its effective range against ground targets was 1,200 to 1,600 meters with high accuracy. It was mounted in a ventral niche without a fairing, which simplified installation and maintenance and provided effective cooling during firing. However, each salvo risked blowing fuses, damaging feeders and connections, disabling equipment, and causing critical damage to precision systems. The shockwave could crush the nose landing gear doors, and the landing lights were frequently shattered during firing. The weapon produced a loud, reverberating thud when fired. The H-23 missile presented several issues. Its high cost, equal to a regiment's monthly pay, significantly limited live-fire exercises. As an early Soviet air-to-ground missile, it became obsolete soon after its introduction. Launching the H-23 also consistently damaged the centralized fuel filler hatch because of improper mounting on the MiG-27. The aircraft's official weapon load was 4 tons. Adding DZU-1A pylons to the tail racks allowed it to carry 500 kg bombs, increasing the total ordnance load to 4.4 tons. The MiG-27's most significant shortcoming was its lengthy pre-flight preparation, requiring 2 hours and 10 minutes per aircraft. Mounting a pair of R-3S air-to-air or H-23 air-to-ground missiles took 1 hour, 18 100 kg bombs needed an hour and a half, and 6 500 kg bombs took nearly 2 hours. A live system check took half an hour. Poor standardization, the need for specialized tools, and difficult access to many components made the ground crew's lives miserable. For example, accessing the fuel filter, wing hinge, or flap mounting points was time-consuming. Recharging the hydraulic accumulator required removing the hatch over the right tail bomb rack, which involved removing 30 screws of 4 different types. Hatches across the airframe were secured with screws, latches, and bolts in 40 different sizes, all unmarked, making the ground crew's work a nightmare. The fuselage's welded steel panels, especially those on the center number 2 fuel tank compartment, developed seam cracks after several hundred flight hours, resulting in fuel leaks. Noticeable kerosene leaks also occurred along the wing box panels and the number 1 and number 3 fuselage tanks. Belarus, India, Kazakhstan, Russia, Sri Lanka, Ukraine, and the USSR were the operators of the aircraft. The single-seat MiG-27 had a length of 16.7 meters, a wingspan of 13.97 meters, and a height of 5 meters. Its wing area was 37.27 square meters. The aircraft's empty and maximum takeoff weights were 11,030 and 20,423 kilograms, respectively. Powered by a 112.8 kilonewton R29B300 afterburning turbojet, it achieved a top speed of Mach 1.7. The aircraft had a range of 2,220 kilometers and a combat radius of 780 kilometers. Its service ceiling was 15,600 meters, equivalent to 51,180 feet. The MiG-27 featured one 30mm 6-barreled Gusha 630A rotary cannon and could carry up to 4,000 kilograms of weapons on 7 hardpoints. It could be armed with R-3S and R-60M air-to-air missiles, H-23M air-to-ground missiles, rocket pods, and various types of bombs. Initially designated as the MiG-23BK, the MiG-27K was developed after the Kyra-23 targeting system. The aircraft featured the advanced SPO-15L Berioza-L radar warning receiver, which identified radar type, bearing, and operating mode. It was also equipped with the new Siren jamming system and could launch H-25, H-27, H-29L, and H-29T missiles. 197 MiG-27Ks were built with the NATO reporting name of Flogger-J2. Work on the MiG-27R reconnaissance variant never progressed beyond the preliminary design stage. Although the MiG-27K's Kyra-23 system offered advanced capabilities, it was costly and complex. To address this, the Soviet Air Force requested a simpler, more affordable variant, which led to the MiG-27M, whose NATO reporting name is Flogger-J. Mikhail Igrievich produced 162 MiG-27Ms and converted 304 MiG-27s to the M standard, which were redesignated as the MiG-27D. A MiG-27 was converted into a test aircraft for land-based trials of the landing arresting gear system, which would be used on combat jets operating from Project 1143.5 class carriers. The export version of the MiG-27M, designated as MiG-27ML, was supplied to India in knockdown kits for license assembly in 1986. The Indians called it Bahadur and built 165 units. Spare parts supply of the MiG-27 in the Soviet Air Force was unreliable. As a result, parts from non-operational aircraft were used to maintain others, reducing squadron-level availability. In the early 1980s, following several serious accidents, pilots began ejecting from the MiG-27s shortly after takeoff, citing engine malfunctions. However, investigations did not confirm any such issues. Despite many issues, the USSR continued to equip many squadrons with the MiG-27. The Flogger-D, J, and J2's safety record was in fact significantly better than that of other frontline Soviet aircraft, and it performed its intended role within acceptable standards. In particular, its nose design, inherited from the MiG-23BN, was praised for its excellent visibility, which facilitated navigation and target acquisition. As pilots gained experience with the MiG-27, many developed a strong appreciation for it. The aircraft forgave everything except carelessness. The production infrastructure was well suited to the rapid manufacture of numerous affordable MiG-27s. It was an essential factor for an armed force preparing for total war. The Soviet Air Force's decision to impose restrictions on pilots rather than addressing technical issues reflected the first Cold War era emphasis on quantity over quality. The MiG-27 required minimal conversion time and effort, while introducing a new aircraft would have been a lengthy and complex process. The USSR deployed most of its MiG-27s to the Chinese border, where in the 1970s and 1980s, the aircraft was far superior to what the People's Liberation Army Air Force had. Some served in Europe as well. The USSR used the MiG-27 during the later stages of the Soviet-Afghan War from 1987 to 1989. Due to the manpads threat, they rarely fought below 5,000 meters, limiting their ability to use guided munitions. During the Kargil War, Indian Bahadurs bombed Pakistani positions. On May 27, 1999, an Indian MiG-27 ML crashed on Pakistani soil, possibly as a result of a manpads hit. Sri Lanka acquired MiG-27s from Ukraine, which played a key role in bombing and close air support missions during the Civil War. The country lost 5 aircraft, 2 on the ground due to attacks and 3 in accidents. Many do not consider the MiG-27 a particularly successful combat jet. It inherited many of the MiG-23's design flaws. Its combat career was not glamorous. Nevertheless, it was the next step in the evolution of the attacker Flogger and has a certain charm for fans of the First Cold War era. Thanks for watching our video. And please don't forget to subscribe to our channel and click the bell button to be notified of our new videos. For more contents like this, please consider clicking the join button to support our channel. And as always, we would greatly appreciate all of your likes, comments, and shares.